Alright, in this video I'm going to show you the notes that we're going to be taking for section 5.2. But the first thing we always want to start with is our learning targets for the day. So in this one, and you should have these in your notebook already because we glued them in at the beginning of chapter 5. But really today we're going to be looking at using the properties of rational exponents and then using the properties of radicals to simplify and write some different expressions. So those are our big two learning targets that we're really going to work on today during these notes and when you start working on your homework. So what you really need for today, it's pretty simple. You definitely need your notebook, and then you will need something to write with. And in this one, color's not super hugely important, so whatever you want to write with. And then you will also need a highlighter at some point. Then the sheet that you're going to need looks just like this. So go ahead and just take a second to find those things and get ready. The other thing you're going to need to do is cut on each of these lines so that we have some flaps to fold. So go ahead and do that, and then we'll get started on our notes. So here we go. It's going to be all folded like this, and you can see we have a flap for each of our different powers. Now, if you're looking through your book, these are just those core concepts from this section. We're just kind of simplifying what they look like. So first, let's talk about the product of powers. So first, we have to think of what the heck product means. So product means I'm multiplying. So I see I have two different terms with the same base, and here we're going to say our base is a, and I have different exponents. So my base is the same, and I'm multiplying. That's where the power, the product comes into play, and I have two powers. So when I multiply those together, I add my exponents. So it becomes a to the m plus n. So over on this right side, we're going to be writing our like math kind of example, and then over on this left side, on this flap, we're going to write what we're doing. So that's what I want you to go ahead and do by yourself. So just knowing that when we multiply our bases with different exponents, we end up adding the exponents. So now let's look at the power of a power. So that tells me that I'm taking a base that has a power already, and I'm taking that to another power. So what do I do there? Well, I'm not multiplying my bases. Here's where I multiply my exponents. So I end up with a to the m times n. Okay, so again, on this left side, go ahead and write yourself some words of what we just did. Now we're going to look at the power of a product. So now it's similar to this top one, but you'll see that the words are in a different order, and that actually means they're doing different things. So here I have a product, and I'm taking a power, right? That's a power of a product. So when I'm doing something like this, I can go ahead and distribute that exponent into both things. The only reason I can do that is because I'm multiplying here. I can't do that if there's addition or subtraction. But here, since I'm multiplying, I have a to the m times b to the m. So I've distributed that exponent. So now let's look at a negative exponent. What does a negative exponent do? Because we're going to have to simplify a lot of these things, and we need to kind of know what they're doing. So if I have a negative exponent, what that really does is it flips its place in the fraction to become positive. So all it does is make it positive. If I started with a negative exponent in the denominator, to make it positive, I would just move it to the numerator to become a positive exponent. Well, here, I now have to put a stipulation on this. A cannot equal 0, right? Because I can never divide by 0. So when I have some variable in the denominator, I have to go ahead and mark that it can't be 0. So go ahead and make sure you remember that when I have a negative exponent, I flip its place in the fraction. Well, what if an exponent is 0? Like, what if I have something to the 0 power? So here we're just going to use a to the 0 because we've been using a. So the thing when I have a 0 exponent, it equals 1. And this does not have to be a variable or anything. It can be a number. Anything to the 0 power is 1. That's just what we kind of have to remember. But we also have to stipulate here that a cannot equal 0 again, just because that would not make any sense. Okay, so now we're going to look at our quotient of powers. So we looked at the very beginning, we have product of powers, and that was multiplying. Now we're looking at quotient of powers. Quotient means we're dividing. So when I had that product of powers, I was multiplying two things. So now here I am dividing two things. So I have a to the m divided by a to the n. Well, up here when I was multiplying, I added my exponents. Now that I'm dividing, I subtract my exponents. So that's kind of our big thing, is that subtraction sign. And again, when I'm having a fraction, I have to make a stipulation that a cannot equal 0. So now let's look at the power of a quotient. Okay, we looked at the power of a product, and now we're going to look at power of quotient. Quotient just means we're dividing. So that's our real only difference there. So again, if I'm multiplying or dividing inside my parentheses, that is where I can go ahead and distribute that exponent to both terms. So I'm going to have a to the m divided by b to the m. But here again, I have a fraction, so b cannot equal 0. One thing I want you to notice is when I have these equal signs, it does not mean that I just go from here to here. If you're given an equation like this, where they have the same exponent, you can work backwards and kind of combine your terms and simplify that way as well. An equal sign means we can go both ways, not just the one way. Okay? So now let's finish our last couple. These are our radical properties. Okay, this is that second learning target that we said we were going to work with today. So we have the radical product property, and the radical quotient property. Now remember, product means multiply and quotient means divide. So our radical product property tells me that if I'm multiplying two things inside of a radical sign, I can split them out and look at them separately. Just like this. So what I was multiplying inside, I can now look at each piece. And this is going to come in really handy when we start actually simplifying radicals and using these properties. Okay, that's what your homework is all about, is taking these properties and actually using them. So I can break things down inside, and then I can separate them out to actually simplify. Okay, so just like that, when I was multiplying inside with my quotient property, if I'm dividing inside my radical, I can separate that out and have the numerator and the denominator. But again, since I have this denominator, I have to tell myself that b cannot equal 0, because I cannot be dividing by 0. So again, if we can simplify things inside the radical to our multiplying or dividing, I can separate them out. So now what you're going to do is you've got all of these different explanations filled out. So now we're going to go ahead and put them in our notebook. Now let me show you what that can look like, because this paper is actually bigger than our notebook. So what I want you to go ahead and do is, in your notebook, give yourself some space to write some examples, if that helps, is you're going to fold up this bottom piece, and it doesn't matter really where you fold it, and then you're only going to glue or tape this very top piece into your notebook, so that when you open your notebook, this part stays here, but it folds down, and then you can fold each of these out so you can see exactly what we're looking at. So what I'll be looking for this part on your notebook, for your notebook check, is, do you have your math examples filled out? But then also, have you given yourself some words, some definition, your own personal definition of what it means? Okay. So there's one more thing we're going to add to our notebook that's not one of these papers. So you're just going to need to write this one down. So this is some other key information. So during this section, you're going to be simplifying some radicals. So we need to know what simplest form actually means. So there are some things, some check marks we have to check off in order to know that we are in simplest form. So the first thing is that no radicands have the nth powers as factors. That just means I have to simplify everything inside the radical sign first. And if you want to walk through an example, we sure can in a little bit. Okay, so that's our step one. So the second thing is, we don't have any fractions. We don't want to deal with fractions. We want to go ahead and separate those out and then simplify. And then the third thing that you'll see a lot is that no radicals are in the denominator. So how we can get rid of radicals in the denominator is by using the conjugate. Okay, and the conjugate tells me that if I've got some term plus a radical, right, and either one of these can contain radicals, they don't both have to, then the conjugate would be the opposite sign in the middle. So if I'm given a root b plus c root d, then I know my conjugate and how I would use it to get rid of the radicals in the denominator would be a root b minus. That's where your highlighter comes into play, because it's really important that you note that these two signs have to be different. If you're given a subtraction, then your conjugate has to be the addition. Okay? And this we go ahead and use to simplify the denominator when I'm adding or subtracting a radical in the denominator. Okay? So now what I want you to do is I want you to go ahead and open up your textbook, either online or your physical textbook, and just briefly look through those examples in there and see if those make any sense. And now you've taken all of your notes for this section. So now you can go ahead and actually start working on that homework. But make sure when you're working on your homework that you have this notebook with you and you have those examples as things you can use. And as always, come see me when you get stuck.